Hi. Most of you follow this course because you want a more evidence-based view of nutrition. And with evidence, I mean scientific evidence. And my role as the professor of this course is to bring you into contact with that scientific evidence. But before we get to that stage, I want to address a more or less philosophical issue and explain to you what nutritional science can deliver and what it cannot deliver. And I want to illustrate that by starting with a claim on a type of food that's very hyped up right now, coconut oil. And the claim is, virgin coconut oil protects against diabetes. And I think most of you would agree with me that you should not boast that claim unless there is evidence to support it. But what do we mean with evidence? Some people may find that their own personal experience is enough evidence to support that claim. But scientists want that claim to be supported by what we call empirical evidence, meaning information that's acquired by careful observation or experimentation. What we mean with that are actual scientific studies that demonstrate that virgin coconut oil protects against diabetes. And without that scientific evidence, scientists would reject that claim. Now, please keep in mind, though, that because the claim has not been scientifically substantiated doesn't mean the claim is necessarily false. It could be that the connection between virgin coconut oil and diabetes has actually never been studied. In that case, we scientists should be clear about it and indicate that we simply don't know, and that there's no empirical evidence to support it. What also happens is that people make a claim and then challenge scientists to demonstrate that the claim is false. Like in our example, someone comes up with the idea that virgin coconut oil is protective against diabetes and then challenges scientists to disprove it. But as in a court, if you want to accuse somebody of a crime, you need to provide the evidence to support the guilt of the defendant. And for good reasons. We don't have a legal system where a defendant is guilty from the start and needs to demonstrate his or her innocence. No, the burden of proof is on the one who declares, not on the one who denies. So if you're making a claim or an argument, you need to be able to back up that claim by providing the source and the actual evidence. And that evidence needs to be solid. The claim needs to be scientifically substantiated. And that may seem like common sense to you and me, but not everybody thinks that way. I want you to get an appreciation of how we collected scientific evidence and how all the scientific studies done in the past have contributed to our current knowledge. Admittedly, there is a lot that we don't know or for which science is not able to present a clear answer. And that's okay. I mean, that means that there's still work to be done. And we also have to accept that some questions will never be properly answered. And we need to accept that certain concepts that we adhered to in the past may not hold up anymore because of a continuous evolution and progression of the scientific evidence. And that's why scientists are reluctant to talk about facts or the truth, because that would imply that the evidence is final. Of course, certain knowledge is pretty fixed, like how fat is transported through the bloodstream. But when it comes to the relation between nutrition and health, there is often a lot more uncertainty. And that's why we label the strength of the evidence from convincing to probable to inconclusive. And whether the evidence is labeled as convincing or probable or inconclusive has a lot to do with how the evidence was collected, via what type of study. And that's why I think it's very important that you learn the basics of research methodology, because research forms the basis of nutritional science. And that's what we're going to do in the beginning of this course.